Combinations are when you choose a group that's small out of a larger population, and the order of the people chosen does not matter. It's just a big group. A combination is a way of selecting several things out of a larger group where order does not matter. Let's choose 3 of these plants to put on a smaller shelf. How many different groups of 3 can we choose? Notice from the wording that it doesn't use the words arrangement or placement or order. It just says how many different groups of 3 can we choose. So if we numbered the plants, what we're looking for is how many different ways can we put 3 of those plants in a group together. Like 1, 2, and 3 could be together in a group, or 2, 3, and 5. Order doesn't matter, so we're not going to list separately a group with 2, 3, and 1, for example. Those are the same groups, so we don't count those. It's different than permutations because the order doesn't matter. That means that there will be fewer combinations because we're going to eliminate all the duplicates. Just like permutations, there is a formula for calculating combinations. Notice the black part of the formula is the same as the permutations formula, but it has something extra. By taking this, the number of plants in a group, factorial, we're taking out all the different arrangements that might occur because those are all duplicates to us now. So we're dividing those out. That's the new formula. Let's figure it out for our plant problem. So for this problem, the total population is 5 plants, and our groupings are 3 plants each. So those are our 2 variables for the formula. We're looking for C53. We've got 5 factorial in the numerator, 5 minus 3 factorial times 3 factorial in the denominator. And if we simplify, that turns into 120 in the top, and this is 2 factorial, which is 2. 3 factorial is 6, so 2 times 6 is 12. And the total number of combinations turns out to be 10 combinations. According to the question, how many different groups? So the unit is groups. That's the word that was used. So I'm going to use that in my answer. Okay, this is the setup you need to show, and this is the answer. Make sure they're both really clear. You don't have to show the individual calculations, just use a calculator. Okay, now we've got a coach that's trying to make teams, right? So we want to know how many different groups of 4 kids could the coach pick out of these 8 children. So our N is 8 and our R is 4. So let's figure this out. We have C, 8, 4. So the numerator is factorial of 8. And in the denominator, we've got 8 minus 4 factorial, which is going to turn into 4 factorial, times 4 factorial. Okay, I think this is going to be a pretty big amount, so I'm just going to go ahead and calculate. In the top, it turns into 40,320. And in the denominator, we've got 24 times 24. If you multiply that out and reduce, you get 70 groups of children. Can you believe that? So 70 different ways that coach could randomly choose 4 kids to be on a team together out of the 8 kids in front of her. All right, how about this one? Committee work. We want committees of 8, and we've got 100 people on a staff. This is going to be a big number, right? So we've got 108. And remember, that is 100 factorial in the numerator, and then we've got 100 minus 8 factorial times 8 factorial. You probably want to do the whole thing on a calculator. Just remember that when you put in 100 and factorial, you hit the division symbol. I would open parentheses before doing all the calculations in the denominator. Now 100 minus 8 we can do mentally, that's just 92, right? So do 92 factorial times 8 factorial, end the parentheses, hit the equals button, and that will calculate correctly. If you don't use parentheses, you're relying on order of operations, and it's going to go left to right, and it's probably going to do this first before it multiplies, and that puts 8 factorial in the numerator actually. So it is important to use parentheses when you have a complicated denominator. This one turns out to be in the billions. 186,087,894,300 committees. So this is a good example for you to try the calculations and make sure that you get the same answer that I'm getting. And that'll tell you if you're hitting the buttons on the calculator in the right order and using parentheses correctly. Here's a common problem. Lots of people get confused between permutations and combinations. You have to be able to recognize which one you've got so that you know which formula to use. So let's go over a few examples. In the first question, we have how many sets of 3 bracelets can I choose from my collection of 12? Sets of 3 bracelets doesn't say anything about order, so that's a combination. In the second one, how many ways can the top 3 skiers be placed out of 22 competitors? This is a permutation because we're placing them in order as first place, second place, third place. How many different handfuls of pens can you grab from a drawer of 108 if 5 pens fit in your hand? Well, a handful of pens clearly isn't in any kind of order, so that's a combination. How many different 4-person sales teams can we put together out of 32 Girl Scouts? A team is a classic combination problem. Remember the kids getting picked by their coach for teams? That's a combination as long as those 4 people are just a group, a team together. Last of all, how many slates of officers can be chosen if we need a president, a secretary, and a treasurer? And there are 260 students eligible for office. This is a permutation because the 3 things we're choosing is not a random grouping. It is specific titles, president, secretary, and treasurer. So the order that those 3 people get named in is going to make a difference. That's a permutation. I really hope that helps. It's a confusing subject. You may want to go back and watch this video over again to make sure you've really got it straight. Or you can go straight to your homework.